All right, lesson 17, student page 97. Verify that quantity a minus 5 times a plus 5 is equal to a squared minus 25. Well, I'm going back to my old favorite. A minus 5, a plus 5. I'm going to draw my box, and I'm going to fill it in. So we have a times a squared, a times negative 5, negative 5a times positive 5, 5a, 5 times negative 5, negative 25. This diagonal cancels each other out. That's a zero pair. Don't want to lose my negative, and we get a squared minus 25. And that does equal a squared minus 25. Interesting. 1 minus, 1 plus, and we got a match. All right, let's see if it works as well for this one. A little trickier because 88, I don't even want to think what 88 squared is. Oh, they're not going to make us think what it is. We just get to write 88 squared. That was very nice. So, okay, does it matter if I go across the top or down the side? No, let me show you. X minus 88, x plus 88, and what we have is we have x squared, 88x, negative 88x, and negative times a positive, 88 squared. Another set of zero pairs, that's gone, equals x squared minus 88 squared. Match right here and right here. Yay! And so, of course, if we're going to do that, we need to look at a general rule. And the general rule would be, does a squared minus b squared equal a minus b quantity times a plus b? Well, I guess we're going to find out, huh? Another box? Oh, I could even get really creative. Don't let this bother you. A minus b, a plus b. Doesn't really matter. All these boxes still have the same address. A by a squared. This one's a times negative b, negative ab, a times positive b, ab, negative b times positive b, negative b squared. Here we go. I see a zero pair again. There's my zero pair. And so we get a squared minus b squared. So exciting. This guy is equal to this guy, which is equal to these. I like this. All right. Well, that was fun for what it lasted. Now we got to look at this guy and see what we can do. All right. This problem is a little trickier, but this problem says, let's think about x squared minus 9. And if you think about this pattern, we had a squared minus 25. That was a minus 5, a plus 5. 5 is the square root of 25. 88 was the square root of 88 squared. And we had b squared being the square root of b. So let's think about this. I'm seeing for negative 9, what I'm thinking is plus or minus 3. So I could factor this guy into x plus 3 times x minus 3 equals 5 times x minus 3. That wasn't so bad. And now, again, I got to go back to my old strategy of solve for 0. So that's what I'm going to do. I'm going to subtract this guy, subtract him. I'm going to bring him over and change the sign. Change sides. Change sign. Change sides. Change sign. Okay, here we go. X plus 3 times x minus 3 minus 5 times x minus 3 equals 0. Notice we have a common term in both of these, so that's the guy coming in front. X minus 3 doesn't really have to go in front. He could go in back too, but I just thought it maybe better tell you that. And then we're going to see that's gone and that's gone, and we're going to put the rest of what we have together, which means we're going to put x plus 3 minus 5. X plus 3 minus 5. And we don't really have any sign problems with this one. So we have x minus 3, and plus 3 minus 5 is x minus 2. And it looks like we have x equals 3 or x equals 2. Nice. All right, well, that wasn't too bad. Now we're going to do the same thing. We're going to solve for w. Now, if I look at this, I've got w plus 2 and w minus 5. When I look over here, I see 4, and 4, the square root of 4, makes me think about plus or minus 2. So I'm feeling pretty confident with this plus 2 over here. W plus 2 times w minus 5 equals w plus 2 times w, that's not w, that's a 3. We'll get this. W minus 2. All right, I like that. So again, I'm going to change sides and change signs. Make it negative. Make it, really I should say the opposite, because that's really what's going on, opposite. Lots of ways to think about the same thing. W plus 2 times w minus 5 minus, as I just said, I was going to make the opposite, so we're trying to get rid of that equal sign. And then we're going to go ahead and say w plus 2 times w minus 2. Boom. Oh, equals 0. Okay, we got it. Uh-oh, made a mess. Okay, here we go. That's out of my way. Common term, w plus 2, w plus 2, and then what we have is we have w minus 5. That's gone and that's gone. Minus w minus 2. Well, this one's interesting. This is going to be a little different. When we combine the like terms here, this is going to turn into w plus 2. And then we've got w minus 5 minus w plus 2 equals 0. W plus 2, and then we got w minus w, and negative 5 plus 2 is negative 3, which is 0. So this negative 3 really doesn't have any effect on this. We could divide both sides by negative 3. It wouldn't hurt anything. And we'd end up with w plus 2 equals 0, and we'd find out that w was negative 2. And that would be our only value on that one. Very nice. Okay. A word problem. This is a tough one, I'm just going to tell you. A string 60 inches long is to be laid out on a tabletop to make a rectangle of a perimeter of 60. Well, the first thing I better do is make a rectangle. And it says the perimeter is 60. So we know that P equals 60. We just have to write down what we can. Write the width of the rectangle as 15 plus x. 15 plus x, and it's a rectangle, that means opposite sides are 15 plus x. And it says, what is an expression for the length? Well, here's the tricky part. I guess I could call this L, or I could say that it was 60 minus 15 plus x minus the other 15 plus x. And that would give me the two L's, this L here and this L here. So that'd give me 2L. let's see what happens. 60 minus 15 plus x, minus x, since it distribute that negative all the way through, right? And then we're going to get, what are we going to get? I think this is going to be a bad disaster. Let me see. Then minus 15 minus x equals 2L. Well, 60 minus 15 minus 15 is 30 minus 2x, which is going to equal 2L. If I divide everything by 2, I'm going to divide everything by 2. I'm going to get 15 minus x equals L. Oh, interesting. So my L is going to be 15 minus x in both cases. And now that means I don't need to think about L anymore, because now I have everything in terms of 60. Very interesting. If I add x here, I'm going to subtract x here. 15 plus 15 plus 15 plus 15. 4 times 15 is 60. All of this makes sense. It holds true. All right, next part of the question. Oh, so yeah, let me box this in. There we go. And we got this one. What is an expression for the area? Well, area is always length times width, right? But what we know is that our length is 15 minus x, and our width is 15 plus x. And this looks exactly like, well, it looks a lot like that a minus b, a plus b. So we know that our area is 15 squared minus x squared. The two middle terms fall out. Or a is 225 minus x squared. All right, now here comes the difficult part. It says, what value of x gives an area of largest possible value? Well, what I'm going to do is I'm going to go ahead and create myself a little box here. I'm going to go ahead and say, how can I get the biggest value for a? And we know that it's going to be based on x, and the middle is 225 minus x squared. Well, let's let x be 0. If x is 0, it's 225 minus 0 squared is 225. And very quickly, 225 minus 1 squared, that's 224. It's already getting smaller. If I put a 2 in there for x, I'm going to get 225 minus 2 squared, 221. 3 in there, 225 minus 3 squared. And hopefully you can see 225 minus 9 is 216. As you can see, the area is getting smaller and smaller. And so if we're trying to find, it says, what value of x gives an area of largest possible value? It's pretty easy to see that x equals 0 gives us the biggest of the numbers. And it says, describe the shape of the rectangle for this special value of x. Well, if x is 0, then the shape of our rectangle is 15 plus 0, 15 minus 0, 15 plus 0, and 15 minus 0. I hope you know what that shape is. Did you write square?